Hey guys, welcome to math class, and it looks like this is going to be probably our norm for the next couple of weeks anyhow. Hope everybody's doing well. I'm seeing you guys every day. Unfortunately, there's not a whole lot we can do about it right now, but I still want to try and get this year finished on a strong note, so we're going to keep going on Chapter 7. So this is how we're going to do notes. So, if I'm taking them, you can take them. What I want you to do at home for your assignment today and anytime you have videos, get the notes down, copy them, and we'll go from there. If at any point, guys, mine are already pre-wrote out, I'm moving a little too quickly for you, go ahead and just pause the video, write it down, press play, and we can go through it kind of together at a better pace, or whatever works best for you. Don't sit at home, just watch this and say you're done. Write them down. It'll help study for your tests and quizzes. So, 7-4, probability models. This was the last lesson that we kind of left off with before we had left for spring break, or a week before break anyhow. And so let's be probability models. A probability model includes a couple of things. It includes our sample space. It also includes the events in the sample space and their probability of happening. Let's look at a problem. Let's kind of get a better feel for what that means. We got 3 story problems. Let's get through them together, guys. So number 1, Mr. Garrett has a jar of 10 marbles. There is 1 red, 3 green, and 6 purple marbles. Students draw marbles at the end of class, and if a red marble is pulled, they get a free dress pass. So essentially, I've got this jar of marbles on my desk. There's 10 marbles in it. There's the color breakdown. And if you pull that 1 red marble out, you get a free dress pass to use at whatever time you like. I want you to create a probability model for the situation described above. Now, our first instructions in this is a probability model includes a sample space. So we need to create a sample space in our answer here. A sample space, all it does is, guys, it lists out all the possible answers. So my sample space for this problem is simply going to be listing off all the possible marble outcomes that I could have. So I could have a red marble. I could have a green marble. Instead of writing that out 3G, because 3G doesn't really tell me much, I'm going to write G out 3 times. And then I also have 6 purples. So I'm going to write a P for purple 6 times. And 6. So there's my sample space. The last thing that this includes is the events in the sample space. So here's my events. My events are red, green, and purple. So I want to list those out with their probability of happening. And this is where the probability model begins to kind of separate itself from anything that we've done in Chapter 7. But I really like it, guys, because it breaks down probability for many things at once. So for this problem, I could find the probability of the red marble, the probability of a green, and also the probability of purple. So those are my 3 different events, and now I need to find the probability of them happening. Remember, when we do probability, we want a fraction. The number on top is how often it's there, or the favorable outcomes, and the number on the bottom is my total. So my red, well, how many red marbles do I have? I have 1. My denominator, I want to know how many marbles I have in all. That would be 10. So the probability of pulling a red marble is 1/10. We could also turn that into a percentage. You have a 10% chance of pulling a red marble. Not a great percent, but at least you have a chance. Next, we need to find the probability of a green marble. Your work is not done, guys, once you have found just one. To complete the probability model, you need to find the probability of all your events. So the probability of a green. How many do I have? I have 3, still over 10, because there's 10 total marbles in the jar. And again, we can find that percentage as well. So 3 over 10, 30%. Last one, purple. We're going to do it the exact same way. So how many purple marbles do we have? We have 6 over 10. That fraction can actually be simplified into 3/5, and that would be equal to 60%. So now we have a probability model. We have a sample space that lists out all of my possible outcomes. I also then have my different events, and those events are red, green, and purple. And I also have the probability of them happening. So the probability for red, 1/10. Probability for green, 3/10. And the probability for purple, 6/10. So this is the probability model. I have everything on here, and I also have everything on here that's going to answer almost any question that you have to ask about probability of this event. I did leave up here probability of red kind of a standalone because that's what this question kind of focuses on, because if you pull a red, you get a free dress pass. So probability of a red, it is a 1/10, or you have a 10% chance of happening. That was just kind of a little extra with this question to kind of satisfy what they were looking for. But if they were asked for a probability model, we need all this information here. It may seem like a lot, it's really not too bad. Let's move ahead. Let's look at part B, two-part question here. Alright, so for part B, Mr. Garrett takes the same jar and adds 10 yellow marbles. What happened to the probability model? My probability, probability of red makes this happen. You still get a free dress pass. So the only thing that changed, guys, I'm taking all this information up top, and I'm adding in 10 yellow marbles. How is that going to make my probability model change? Well, it's going to make it change a couple of ways. First off, my sample space. My sample space tells me all of my different outcomes from pulling marbles out of the jar. Well, I still have red, green 3 times, and purple 6 times. 3, 4, 5, 6. I also have 10 yellow marbles now. So my probability model has changed. It's not the same anymore. So we can list all 10 yellow, 2, 3, 4, 5, 6, 7, 8, 9. Let's add one more. Alright, so there's my sample space. It has all my different outcomes possible. Next, I need to create this probability model of these different events. The events in the sample space, those are not going to change. I'm still going to have the probability of red. I'm still going to have the probability of green and the probability of purple. I'm just adding to this the probability of yellow. And now we can go through and we can find their different probabilities and how often they happen. So for red, how many red marbles do we have? We still have 1. This time, how many marbles do I have? Well, I had my previous 10, and I added 10, so it's now 1 over 20. For green, again, there still are 3 green marbles. My denominator is now out of 20, so 3 over 20. My probability of purple, there are still 6 purple marbles. Now there are 20 in the jar, 20 total in the jar. And this fraction can also be simplified. Divide my numerator and denominator by 2. We get 3/10. And last but not least, yellow. How many yellow marbles do I have? I have 10. How many total in the jar? 20. So my probability here, 10 over 20, would be 50%. So something you might be asked on this type of question. For number 1, part A, my probability was 10%. Well, how did that probability change after you made your probability model. You might ask yourself, 1 over 10 and 1 over 20. Which one has the better odds? Well, the better odds would be 1 out of 10 because there's fewer items to pull from. You have a greater chance of pulling this 1 out of 10 things than you do out of pulling it out of 20 things. So my percentage actually goes down. So my probability of a red, which is 1 over 20, is actually now at a 5% chance of happening. So my percentage has came down as I've added more marbles into the jar. So our sample space changed. Probability model kind of changed. All we did was we added a yellow option. And then also the probability of these events happening, that changed as well. Because all of these now have 20 as their denominator instead of 10. Alright, let's move on to number 2. Move on to our next problem. For number 2, here, I have a chart for you, not as much of a word problem on this one. For number 2, we have the colors. Our colors are red, blue, and green. And then these numbers represent the number of marbles drawn. So I have a jar again. This chart shows the marbles drawn. There are 30 in all that will pull from the jar. So this jar, 30 marbles pulled out. 4 were red, 11 were blue, 15 were green. I want you, what can you conclude from this? Create a probability model. Anytime guys are asked what can you conclude from your data, create your probability model. It's going to tell you the probability of everything happening, and then you have a better idea as far as what's actually going on with your data. So let's go through and let's make a probability model here. So for my sample space, I have the different options of red, blue, and green. Then when we start to make our probability model, I have the probability of finding a red, I have the probability of a blue, and I also have the probability of a green. Now let's go through and let's find their probabilities of them happening. So for red, well, how many red marbles did we have? We had 4 red marbles out of how much? Well, there were 30 in all were pulled. So if there's 30, it's going to be 4 over 30. Another way we could find that is take all your marbles, add them together. 15 plus 11 plus 4 also tells me 30 marbles were pulled. Probability of a blue. We move ahead now. We have 30 also on the bottom here. How many of them are blue? 11. So 11 over 30. And real quick, we can simplify this top one. It actually goes down to 2 over 15. Probability of a green. 15 over 30. 15 green, 30 total. So there's our probability for red, blue, and green. And our probability for the green marble actually will reduce down to 1 over 2, 1/2. So those are our different probabilities. Now my question, what can I conclude? Well, I can conclude that it's more likely that a green marble is pulled out because its percentage is a lot higher than any of my other marbles. It is the highest. Then you have half a chance of pulling out a green marble. So that is my probability model for problem number 2. Last question, number 3. Color, marbles drawn. Again, have another chart. This time I have the marbles red, blue, orange, and green. And in my jar, 7 of them that were pulled out were red, 20 of them pulled out were blue, 1 orange marble was pulled out and 32 green marbles were pulled out. My question wants me to estimate the number of marbles drawn and their probability if 100 marbles were pulled from a jar. Now, it wants to know if 100 marbles were pulled from the jar. If I take all of my numbers and add them together, you should come to find out that there were 60 marbles drawn from the chart. And I want to know about 100. Let's go through and let's create ourselves a probability model first. So again, we have our sample space. My different options in my sample space are red, blue, green, and orange. And now let's begin to make our probability model. I'm going to space this one out a little bit so that way you can see it a little easier. So red, blue, green, and orange. Alright, so now let's go through them. Again, just like what we did up top here. Let's first find that starting fraction, that starting point. I think that's going to be the easiest thing when solving these problems. So my starting point with red, there are 7 marbles out of how many were drawn? 60, not 100. I want to estimate to 100. The 7 represents 60 of the marbles that were drawn. So 7 over 60. Blue. There were 20 blue marbles drawn out of 60. At this point, guys, yes, 20 over 60 can be simplified. You're exactly right if you're asking yourself that. It gets simplified to 1/3. However, we're going to be doing one more step with this estimating part. So, if you don't simplify here, that's okay. Probability of a green, 32 over 60. My last one for orange is going to be 1 over 60. So I have my probability model set up. But the question did not ask for a probability model. It asked me to estimate the marbles drawn if 100 marbles were drawn. Here, only 60 marbles were drawn. So, we need to set up a proportion. Everybody's favorite. So if I set this equal to, I put 100 on the bottom because I want to keep these the same, apples to apples. 60 were drawn, now 100 were drawn. Keep what was drawn on the bottom. I don't know how many out of 100 were drawn. So that's where I'm going to leave an x. To solve for x, cross multiply. So I'm going to do 7 times 100. Set that equal to 60 times x. Simplify. 700 is equal to 60x. And then to get x by itself, divide. X equals 11.6. Repeating. Is it possible to have 11.6 marbles? You should be telling yourself, no. We're estimating. So it would be about, round up, about 12. So about 12 of the marbles drawn were red. We're going to do the same thing, guys, for blue. I'm going to set this proportion up. X over 100. You're going to notice a theme, and they're very similar the more we do these. So for this, cross multiply. So 20 times 100, you're going to get 2,000 is equal to 60x. Divide by 60. X equals 33.3. For the same reason of the 11.6, I cannot have 33.3 marbles. So it would be about 33. That would round down for rounding purposes. This might be a good time in the video to maybe pause it, attempt green and orange on your own. Let's go through and let's do green and orange. So again, set a proportion of x over 100. 32 times 100, cross multiply, 3,200 equals 60x. Divide by 60. X equals 53.3. Same thing as above. This would turn into about 53. And last but not least, orange equals x over 100. Cross multiply. 100 is equal to 60x. Divide by 60. X equals 1.6. Repeating. This number would round up. So about 2. And remember, guys, these are all estimations. Is this going to happen for sure if 100 marbles were drawn? Maybe yes, maybe no. It's about. So this is why we have about 12, about 33, about 53, and about 2. Guys, the big takeaway on this lesson here, probability models, sample space, your different events that can happen, their probabilities. And then from there, we can estimate to find out the different amounts that might happen. Say we were to take a new number and draw out. Guys, this is our lesson today. Shoot me an email, maybe tell me what you think. Let me know kind of how this went for you. Maybe this worked, maybe it didn't. Looks like we're going to be probably doing something very similar to this for the next couple of weeks. Anyhow, missing you guys a whole lot. This is your assignment for today, so make sure you get all these notes taken down in your notebook, and we will pick back up with some more probability models tomorrow. Guys, have a good day.